Everybody's going okay? All right, well, let's continue discussing solving trigonometric equations today. In particular, we'll extend what we were talking about last time. Pardon me, goodness. Extend what we were talking about last time with solving those basic trigonometric equations. So remember, the basic ones are just trig functions. Trig function equals number. That's what we mean by a basic trig equation. And then we had our technique was to find what I referred to those as those fundamental solutions. Find your solutions in one period, usually 0 to 2 pi. Unless you're doing something like tangent, then you can do 0 to pi. Nothing special necessarily about 0 to 2 pi or 0 to pi, just that's typically what we use to find those fundamental solutions. And then we find all the solutions by adding and adding multiples of 2 pi. Unless it was tangent, then we added multiples of pi. So did all those last time. Sometimes we were able to do exact values. Sometimes we had to use our calculator. So we'll see more of those today. We're just going to convert more complicated equations into the ones we've already solved. So let's look at this first example where we've got 4 cosine squared theta plus 3 equals 0. Let's attack this like we've done previous problems. Let's just isolate the cosine squared so we can subtract 3 to the other side. Actually, subtract 3 to the other, the negative 3 to the other side. Oh, crud. Didn't need to do it that way. You know what? Change that plus sign in the middle to a minus sign here. Otherwise, we're going to have a problem. Make it a positive 3. Sorry about that. And then divide by your 4. And you'll see why I just changed that. See a cosine by itself, what should you do to both sides of the equation? Take the square root, right? When we take the square root of a negative number, of course, we get complex numbers. We don't want complex solutions to these equations. We want real solutions to these equations. So I wouldn't take a square root of a negative here. We will actually, after Thanksgiving break, do some problems with complex numbers. So we will do a little bit of complex number stuff at the end of the semester, but it won't be involved in solving equations like this. Okay. All right, so take your square root of both sides. Remember that when you take the square root of both sides of an equation, you'll always get plus or minus. And then I can simplify that a little bit, because if I do the square root of 4 on bottom, we get 2, right? And now notice that we've converted that original equation into basically 2 basic equations, right? We want to know when is cosine equal to positive root 3 over 2 and when cosine is equal to negative root 3 over 2, because those would be, each of those would give solutions. So if we do the fundamental ones, when is cosine equal to either the positive root 3 over 2 or the negative root 3 over 2? Either of them work for us. Say again? That would be if it were sine. It's okay. So instead of pi over 3, we would use pi over 6. Good. That would be the one that's in quadrant 1, right? The one that would be in quadrant 2 for the negative root 3 over 2 would be what? Five pi over 6. We also have one over in quadrant 3. 7 pi over 6. And finally, we got one over in quadrant 4. 11 pi over 6. Good. Those are all ors, right? Pi over 6, or 5 pi over 6, or 7 pi over 6, or 11 pi over 6. Any of those work? Those, again, are the solutions to this equation in one period, right? From 0 to 2 pi. What do we do with each of these now to get all of the solutions? What do we add?
Plus 2 pi n.
2 plus 2 pi n, good. So remember, anything that's coterminal will also give us a solution. So we'll add multiples of the period on the end. And so in this case, we get 4 of those fundamental solutions, 4 solutions in 0 to 2 pi, and then we find all of the solutions by adding the multiples of 2 pi on the end. Questions on that one? That one okay? Well, see if you can do the next one. That cosecant squared minus 4 equals 0. Work on that one for a minute or two, and we'll chat about it. Ready to talk about it? Super quiet day. It was quiet in my last class, quiet in here. All right. Everybody get to this point, very least? Right? Just like we started off the previous one, right? Isolate your cosecant squared to start with, and then take the square root of both sides. Remembering that if you take the square root of both sides of an equation, we need to use plus or minus on the other side. Now, you could go right into the solutions from here if you can remember when cosecant is equal to 2 or cosecant is equal to -2. But if you don't see that off the top of your head, what can I do to rewrite this in terms of a different trig function that might be a little bit easier to see what the solution should be? Yeah, you could do sine, right? Do the reciprocal of both sides. So what would sine of theta be equal to then? Plus or minus a half. Good. So again, if you don't see what the cosecant is, or say the secant is, like we've got in the next example, pardon me, or cotangent, change it into terms of things that you do know. Okay. So now this is asking when is sine equal to positive a half, or when is sine equal to negative a half. Since it's plus or minus, we're looking on all four quadrants, right? So tell me when sine is equal to a half. Yeah, pi over 6 plus 2 pi n. Or else.
5 over 6.
Good.
7 over 6.
Good. Yeah, it's the same answer as the previous problem, isn't it? Because when sine's a half or negative a half is the same place as where cosine's root 3 over 2 or negative root 3 over 2. So those would be your solutions in this case. So again, same process. Find your solutions in one period. 5 over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6. That gives you those solutions in 0 to 2 pi. And then add multiple to 2 pi to get all of the solutions. Okay? Okay, so notice in these first two examples that we did, we were able to isolate the trig function by isolating the square first and then taking the square root, right? Notice that that same technique will not work in the next example, right? Because if I try to isolate the square, I still have a secant on the other side. That doesn't help it, correct? So what we want to do instead is the same types of techniques that you would do in algebra class when you're trying to solve a quadratic equation. Right? Instead of writing that as secant squared theta plus secant theta minus 2 equals 0, if that were x squared plus x minus 2 equals 0, what would you do to solve? If you had x squared plus x minus 2 instead, what would you do? Factor, right? That dirty 6-letter F word, right? Factor. Right? I know it's a bad joke, but I didn't say it anyway. Okay? Didn't say it was a good joke. I tell very few good jokes. Most of them are bad. Okay. All right, anyway. I would factor it. And it's exactly what we want to do here. We want to factor. But what we're going to treat for the x here is that secant of theta. So if I want to factor this thing, I better use secant theta where I would use the x, right? What do the constants have to be to get everything to work out then? Yeah, I better use a plus 2 and a minus 1, right? And now the reason why we factor it and make sure we have 0 on one side is because the only way a product can equal 0 is if what happens? What's the only way a product can equal 0? Yeah, you have to have one of the factors of 0, right? The only way you have a product of 0 is if one of the factors is 0. That's why we have to have 0 on one side. If I have two things that multiply together to give me, say, 6, I could use 1 and 6, I could use 2 and 3, I could use 12 and a half, I could use negative 24 and negative a fourth, okay? Having a number on the other side that's not 0 doesn't help me. Yeah, I have to have 0, because at this point now we can set each piece equal to 0. And now again, we can rewrite these as those basic trig equations again. So in this case, the first equation gives us secant of theta is equal to negative 2. And the second equation gives us secant of theta is equal to 1. Bless you. Bless you again. Thank you. Now again, if you remember when secant's equal to negative 2, or remember when secant's equal to 1, you can go right to the answers from here. However, if you don't remember that, write it in terms of cosine. Do the reciprocal of both sides. Maybe. Well, are you not writing? There we go. Do the reciprocal of both sides, we get cosine of theta equals negative 1/2 or cosine of theta equals 1. For negative 1/2, what quadrants are you looking in for your fundamental solutions? What quadrants is cosine negative? 2 and 3. If we just had the 1/2, what angle has a cosine equal to 1/2? Pi over 3, good. And we want the ones that are in quadrants 2 and 3. So in quadrant 2, we'll use that one's in quadrant 3, but yeah, that's one of them. Good. And the one that's in quadrant 2 is 2 pi over 3. Good. And then again, don't forget your multiples of pi in there. Right? Or multiples of 2 pi, sorry. So the first equation gives us 2 pi over 3 plus 2 pi n, or 4 pi over 3 plus 2 pi n. What about the last equation? When is cosine equal to 1? This one might help to think about what the graph of cosine looks like. When is cosine equal to 1? Two pi, right? 0, 2 pi, 4 pi, right? The multiples of 2 pi. So the last one would just be 2 pi n. You're going to think of it as 0 plus 2 pi n if you wanted to. But that's when cosine is equal to 1. So, okay? Questions on that one at all? Try the next one involving sine, and then we'll chat about it. Same kind of process. We're ready to talk about it? What'd you do first? Okay, good. You need to get that factored, right? This one, not a lot of choices that you have. I need a 2 sine squared, so I better use a 2 sine theta in one of them and a sine theta in the other. Since that's a negative sign there, one is going to be plus and one has to be a minus. If I want to multiply together, they give me a 1, it's going to be 1s. So it's just a matter of getting the signs right at that point. What's next? Good. Set each one equal to 0. Pardon me. And then isolate the trig function in both of them. Isolate the sign. So in the first one, we'd have sine of theta is negative a half. And in the second one, we have sine of theta is equal to 1. Looking at the first equation, what quadrants are we looking in? Third and fourth, right? Because it's a negative sign value. If I just look at the 1/2 part, when is sine equal to a half? 5/6. So I need the pi/6 angles that are in 3 and 4, right? What are those? Good. Good. And then again, for each of those, we need to make sure we add the multiples of 2 pi. So we get 7 pi/6 plus 2n pi, and 11 pi/6 plus 2n pi. So far, so good? And then the last one says, well, we need to know when the sine is equal to 1. Again, sometimes it helps to think about the graph. When does the graph of sine get up to 1? Pi/2, right? And that's the only place between 0 and 2 pi that happens. So we'll get pi/2 plus 2 pi. You can write it as 2n pi or 2 pi n. Either way works. I don't know why I flipped it halfway through the problem, but I did. Questions on that one? That one okay? All right. Let's look at this next one together. Pardon me. We've got 3 cotangent squared plus cotangent equals 30. This one's a little bit different than the previous ones because notice I don't have 0 on the right-hand side, right? So the first thing we need to do is subtract the 30, right? That has to be step 1. Factoring only is helpful if I have 0 on one side of the equation. Okay. So that's step 1, moving everything over to one side. So if you're going to factor, you have to move everything to one side to start. This one might be a little bit more challenging to factor, but it's not too bad because, again, since we have 3 cotangent squared, if it's going to factor, I better have a 3 cotangent in one factor and a cotangent in the other. So now I need to get the correct factors of 30 so that when I put them in here, I get a plus 1 for my middle term. What do I need to use?
Plus 6 minus 5.
If I do a 6 and a 5, I think I get too big, don't I? Because if I do a 6 here, I'd get a 6, and then a minus 15 would give me a 9. Okay. Right? So what else should we try?
Plus 2 minus 5. Or minus 5.
5 and 2 give me 10 though, right? Not 30? Well, you said would have worked if it had been a 10 rather than a 30. Yeah. 10 and 3 will work. Which one needs to be positive? The 10. It better be a plus 10 here and a minus 3 here. Because when I multiply now, I get a plus 10 cotangent, and then I get a minus 9 cotangent. So I get the plus 1 that I need. If you need to, if you haven't seen this before, you can use what's called the AC method to help factor. Let me show that real quick. So rather than writing the cotangents in here. So if you're trying to factor this using what's referred to as the AC method, the first thing you do is you multiply the coefficient on your x squared, which is usually referred to as the A, and the constant, which is the C. Gives me negative 90. And now I need things that multiply to negative 90 that give me positive 1. 10 and negative 9 work, right? So that you rewrite your x as 10x minus x. Or 10x minus 9x, sorry. Yeah, that's better. In this first term here, I can factor out an x. And in the second term, you can factor out a negative 3. And then I've got a common factor in both terms now, which is exactly the factor I came up with. So this always works, by the way, if you do it this way. This is what's, again, called AC method. So if you don't see how it factors right away, try that. Multiply those two numbers together and see if you get factors of this that add to that, and then do this factor by grouping. Like I said, it's a nice little way to do it. What do we do next now for this? Now that we have it factored. Yeah, so that equal to 0, good. And then in each of them, isolate your cotangent. So we get cotangent of theta is negative 10/3, or cotangent of theta is 3. Those don't look like things I know. Those look like values that I know coming out of any of the trig functions, right? We don't have lots of just 3s. We have square root of 3, but not a lot of 3s. Okay. So this is probably one of the ones we're going to use our calculator on. Does your calculator have a cotangent button on it? No. Okay. Probably not. Some of them, if your calculator is fancy enough, you might be able to find an inverse cotangent button on it. Okay. But generally speaking, you've probably got an inverse sine, an inverse cosine, or an inverse tangent, right? So let's convert these to statements about tangents so that you can use your calculator. What do I need to do to convert it to a statement about tangent? Flip it, good. So tangent of theta is negative 3/10, or tangent of theta is 3. Oops. So for the first one then, we want to do our inverse tangent of negative 3/10. Put that in your calculator. What do you get out for theta? Remember, we're doing these in radians.
0.2915. Negative 0.915.
Okay. Remember again, our period for the tangent function is pi. So we only need to figure out answers that work in a 1 pi interval. So it's a little bit nicer when you're using your calculators for these, because whatever value you get out of the inverse tangent is the value you use, and then add a multiple of pi to it. Okay, you don't have to worry about 2 pi, you just have to do a multiple of pi. So that's the first one. The second one, we would do inverse tangent of 3. What do you get for inverse tangent of 3?
Wouldn't it be 1/3?
Oh, it is 1/3. Thank you. I did forget to flip it. Thank you. My bad. Thank you so much. What'd you get for a third then? Inverse tangent of a third.
0.3218.
And then I get pi in. Technically, I probably should write my plus pi in up here too, because I'm really doing that for these. It's using the calculator to approximate the first part. Thank you for fixing my error there. Questions on that one? That okay? All right. Let's look at this next one here. Pardon me. Where we have tangent cubed theta equals 9 tangent theta. Something that's very, very tempting is to do what first? What's very, very tempting? Just looking at it, what's tempting to do? Dividing by the tangent, right? That's very, very, very tempting to do. Unfortunately, that's not the right way to start this. Okay? The reason why you do not want to just try to divide both sides by tangent and cancel off the tangent is because if tangent is equal to 0, if the tangent of theta is equal to 0, can I divide by it anymore? No. Okay. It's bad in general to divide both sides by a variable. Because if it's a variable, I do not know that that variable is 0. I don't know the value of that variable. The value of that variable is 0 or not. Okay? So do not divide both sides by something with a variable in it, just generally speaking. It causes bad things to happen. Okay? Unless you know for a fact that it can never be 0. For example, if you had something like x squared plus 1, that would be okay to divide both sides by, because x squared plus 1 can never be equal to 0. X squared plus 1 is always greater than or equal to 1, because x squared is greater than or equal to 0. But generally speaking, don't divide things by variables. Okay. Causes, dogs and cats to start living together. Raining acid, bad things, end of the world kind of things. All right, it's the same principle here. Set it equal to 0. Now I can factor out a common factor, right? I can factor out a tangent. Looking inside my parentheses now, I see a difference of 2 squares, don't I? Tangent squared theta minus 3 squared. So how is that going to factor? When you factor a difference of 2 squares, how does it factor?
Tangent theta plus 3, tangent theta minus 3.
Good. And now I've got 3 factors, so I can set each one equal to 0. The first one we can actually figure out exact value. When is tangent equal to 0? What do you plug in for theta to get 0 for tangent? Well, tangent will be 0 the same place sine is 0. When is sine equal to 0? At 0, right? So your first one, you just get multiples of pi. That first one's easy to solve. Easier to solve. It's multiples of pi. The next one we would need to subtract the 3 and take the inverse tangent, right? So we'd have inverse tangent of -3. What do you get when you do inverse tangent of -3? Okay. And then again, multiples of pi. Because again, the period of tangent is just pi, so we don't have to go looking for another one. And then remember that your tangent and your inverse tangent function is odd. So if inverse tangent of -3 was -1.249, inverse tangent of 3 must be the positive of it. Questions on that one? Is okay? All right, let's do the next one here. So we got 7 cosine squared theta minus 12 cosine theta equals 4. What do we want to do first before we do anything else?
Subtract 4.
Yeah, better put 0 on one side, right? Get 0 on one side, so move the 4 over. So we have 7 cosine squared theta minus 12 cosine theta minus 4 equals 0. You could do that AC method thing that I told you about if you don't see how it factors right away. But since it's a 7 cosine squared theta, I've got to have a 7 cosine theta for one of my factors and a cosine theta for the other if it's going to factor at all, right? So now I need to end up with -12 in the middle. What do I need to use for my constants here and here in order to get a -12? Good news is that 4 doesn't have a lot of factors, right? You get 1 and 4 or 2 and 2. That's all you got. What do you need to use? +2 and -2. Yep, good. Notice when you put the -2 on the right one, you get a -14 cosine theta, and then the +2 will make up the difference there. Pardon me. Next step. Yep, good. 7 both equal to 0. Good. And then isolate the cosine here. So before we solve the first one, let's look at the second one. When you isolate the cosine after setting the second factor equal to 0, we get the equation cosine theta equals 2. But what is cosine always in between? No matter what, what's cosine always in between? Yeah, negative 1 and 1, right? So what can I say about that second equation?
No solution.
No solution, right? And as a matter of fact, if you try to do the inverse cosine of 2 in your calculator, it's going to spit out an error. Unless your calculator handles things with complex numbers and it defaults to that, and then you might get something that spits out a complex number. But this one has no solution for that one. So now this one, we'll do inverse cosine of negative 2/7. What do you get when you put that into your calculator?
1.8605.
So we get that one solution, 1.8605, and since we're dealing with cosine, we'll add multiples of 2 pi n. Is that the only solution we get, though? So first off, let me ask you, what quadrant is 1.8605 in? So straight up and down, that's pi over 2. Off to the right is, off to the left, my right. Off to the left is pi. Pi is 3.14-ish. Half of that is 1.57-ish. What quadrant is that in? Second. Where else is cosine negative? Third, right? Remember, this is where we have to go hunting for the other solution, right? The inverse, whenever you do inverse sine or inverse cosine on your calculator, it's going to give you one of two possibilities, right? You have to go hunt the second one, right? I like to draw the picture. I think the picture helps me personally. Draw this off to the side. We get that one that's in quadrant 2. We need this one that's down in quadrant 3. Right? How would I figure out this angle? Or you could also go this way. So if I took this angle and added pi, I would end up over here. So that would be on that straight line that goes that way.
You do 2 pi minus.
Do 2 pi minus that? Yeah. So the other one will be 2 pi minus the 1.8605. I could have also just used negative 1.8605. That would also give me all of them because they're coterminal with each other, right? Notice that gets, if I had this here, made that go away. If you put 1 in for n here, it comes up. I get that solution. So either one works. Some of your problems will ask you to find all solutions in 0 to 2 pi, so you should be able to make sure that you can get in between 0 and 2 pi. You know how to do that. That's just playing around with the coterminal angle ideas. If it's negative, just add 2 pi to it, and that'll get you in 0 to 2 pi. That okay? Okay. Pardon me. Looking at this last one here, it's already set equal to 0. What would you do first? Yeah, factor out a sine, right? When you factor out the sine theta, you're left with 6 cosine theta plus 1. And just like every other problem we've done before, We'll set each piece equal to 0. I went ahead and jumped ahead a step and isolated the cosine in the second factor. So we should get sine of theta equals 0, or cosine of theta is equal to negative 1/6. Pardon me. Well, that cosine of theta equals negative 1/6 looks a lot like the previous one, right? Just a slightly different number you're going to put in. It's going to have the exact same format as the previous one did. When you put that into your calculator, you'll get an angle in quadrant 2. You'll have to go find the angle in quadrant 3. Okay. This first one is just asking you, when is sine equal to 0? Where does sine cross the x-axis? At 0 and at pi and at 2 pi, right? So we would write that one as multiples of pi, because it crosses every multiple of pi. And then the other one, you'll do inverse cosine of negative 1/6. That's a calculator active problem. And then you'll do 2 pi minus that same inverse cosine of negative 1/6. It's literally the same problem as you did before. We just changed the number, right? So you put that into your calculator. Did anybody happen to put that in the calculator?
1.7382.
Cool. That okay? All right, so I'm feeling Friday sounds like a good day for a quiz over this stuff. Literally this stuff, okay? So we'll get started in section 5 on Friday. Section 5 is more of the same, except that we're going to use some of the trig identities that we learned to help us rewrite the equation, and then literally do the same stuff we've been doing the last few days. Okay? All right. So we'll do that on Friday. We'll also do a quiz. Your quiz will just be over this type of stuff. Okay? Have a good one. We'll see you on Friday.